I think we are recording. If not, yeah, it's recording. Okay, so let's get started. So in the last class, we ended up with talking about KVL and KCL, which is Kirchoff voltage law and Kirchoff current law. So the question is, what is KVL and KCL? You also understand. So we had to try one or two problems and understand how we actually apply this. So if you missed the last class, the KCL is actually saying that the total current stored in a node point will be 0. For example, if you have a node point like this is a node point. We have a resistor here, resistor here, resistor here. You have high 1, you have high 2, you have high 3. I1 and I3 are going towards the node and I3 is going away. So whatever comes to the node, I1 plus I3 is equal to the whatever going to the node, going outside of the node. Whatever coming in is whatever going out. It's simple as that. This is a common logic. Okay. So KVL is actually Kirchoff voltage law. So KVL actually, as I explained in last class, this is actually, for example, if we have a loop, if I have VA here, if I have VB here, if I have VC here, and if I have VD here, then and the signs are like this. I'm giving voltage like this, plus or minus. Then I will give this like negative to positive. Okay. So the trick is like when you consider this loop, whenever you're going for negative to positive, the voltage you take it as negative. That's it. So here it is like this, right? Negative to positive. So it is minus VA. Here it is positive negative, right? So it is plus VB. Here it is plus VC. Here it is negative to positive, right? So it is negativity. Should be equal to 0. So if I rewrite it, VB plus VC equal to VA plus VD. This is KVL, okay? So Kirchoff voltage law is also simple. So now we will look into one or two simple problems in this using these methods. So we will try to solve just few problems which will help you to get the feel of it. So for example, let's consider you have a circuit. I will just draw some random circuit. For example, I have one voltage source. I will have another voltage source. Then I have another voltage source. I have another voltage source. Then I will just add a 4 ohm resistor. The voltage is V1 across it, and have a 2 ohm resistor. Then I have a 2 volt voltage. Then I have a 5 ohm resistor. I think it is raining outside. Okay, so it is V1, V2, and yeah. So this we will just give a 6 volt, 3 volt, and 1 volt, 5 volt. Okay. So the question is, what is V1 and V2? I want to find what is V1 and V2. How we will find that? So the basic idea is we will apply what? KVL. We want to find the voltage, right? So it is comes under KVL. So this is a loop. I will just write what are the Kirchoff voltage law equation. Here you can see the 6 volt is from negative to positive, so it is minus 6 or minus 6. The idea is like it is always not minus 6. I mean, when we are considering negative to positive as negative, the positive to negative should be positive. Or if you are considering the negative to positive as a positive, then positive to negative will be negative. It should be just vice versa. I mean, that's not a different rule, but it is just that. It's just that meaning. You understand, right? Okay. So if I take, for example, here I'm to confuse you more. I'm taking negative to positive as positive. So I have 6. Then again negative to positive 3. Then the top I have plus 1 again, but here I have positive negative, right? I'm taking as negative. Minus 5, minus 4i, because here I have 4 ohm resistance, and let's consider that I have a I current here. So minus 4i, again the same current is flowing through this way, right? So minus 4i, minus 2i, here we have another voltage, minus 2 volt, minus 5i equal to 0. Okay, So again, then if you just readjust this, like I equal to 11, I mean, not 11, but yeah, it will be, should be 3 by 11, yeah, 3 by 11 ampere. And the voltage is, right, voltage is like V1 equal to 4 into I1, 4 into I, it is 4 into 3 by 11, so it is 12 by 11. Okay, and we got V1. And what is V2? V2 equal to 5 in your 5 row questions, and I 5 is what, right, 5 into 3 by 11, and it is 5, 15 by 11. So V2 you also you got. So you are able to understand, I mean, get what is V1 and V2 using this method, and I think that is pretty simple. Not much hard work is required. Okay, now let's go into tricky problem. I will write a circuit. This we will give. Sorry, we will give this 5 volt. This will give 2 ohm. This will give 4 ohm. Okay, I have nearby one more circuit. It is 2 ohm. This is 10 volt. Okay. I think it is 5 ohm. My handwriting is not good, but still, not my handwriting. My drawing skills are not that great, but still. Okay, so these two circuits I connect by another voltage source, 2 volt. I'm trying my best to confuse you and put you in trouble, so that you will get your hands dirty and you'll understand the concept. Otherwise, like, you'll just say that okay, this is just some should be 0, that is KVL, and other is KCL. But in exams, like, they will ask you some tricky questions and you are done. Okay, so I'll put okay. So my question is, what is VAB? VAB. So what is A and B? I have A point here. I have B point here. I have, what is VAB? That's my question. I want to find the voltage between A and B. Interesting, right? I'll just name this point as X and this point as Y. So if we want, the idea is like, if you want to find VAB, what we should know? We should know VAX plus we should know VXY, right? Sorry. Then we should know VYB, right? Is that correct? Uh, VX plus VXY plus VYB should be known. And the good thing is we already know VXY, right? It is 2 volt. It is evident from the figure. Okay. So now we want to find out VAX and VYB. How will you do that? Of course, solution is KVL. It is such a nice, I mean, it is nice, such a great tool. It will help you a lot in the circuit analysis. And so let's find out Vx. So Vx, for that I am just taking a loop like this. Here also I am taking a loop like this. Okay. So it is in the first loop, it is the second loop. Okay. So in the first loop, when I look at the KVL, when I apply KVL, we have 4 ohm resistor here. We will take that we have some current I1 is flowing through it. Okay. And so minus for I1, then the current is going like this, it is here. So minus 2 I1 plus. So you know that the current is always go from positive to negative, right? So but here you see there is a voltage source moving from negative to positive. So I should take it as positive side, because otherwise you are taking negative, right? So it should be positive. Confusing, right? You should confuse. That's my idea. Okay. And so some should be 0. Then I1, right? I1 you should just rearrange, it will come under 5 by 6 ampere. Okay. Okay. If you know I1, then let's go to loop 2. Loop 2, but how we'll do it? I have a 10 volt here. I just take 10 volt plus, then my current is going in the opposite direction, right? And so you have minus, plus or minus. Should I write plus 2 ohm or minus 2 ohm? You think about it. Okay. So it is like minus 2 I2 minus 5 I2 equal to 0. Do you understand why I wrote like that? I mean, I am taking the loop in this direction, right? So this is the positive to negative, I mean negative to positive, and others are in different orientation. So if it is voltage, like current should go this way, but here the current is going this way, we are taking to like that direction, so it should be in the opposite opposite what opposite symbols. But if it is too confusing, what I would say is there is a simple logic for it. I was trying to confuse you actually first. So simple logic is like, if you take this circuit, so the total voltage, the source voltage is only 10 volt, right? So whatever the voltage comes in the circuit should be come from the 10 volt, right? So this 10 volt should equal to 2i2 plus 5i2. That's the idea. It's simple, right? We need to confuse about plus or minus or nothing. Okay. Okay, so this is that this one. So if you rearrange it, what you will get? I2 should be 5 plus 2, 7, 10 by 7. So I2 should be 10 by 7, 10 by 7 ampere. And that's also clear, I guess. So we got I1, we got I2. So if you know I1 and I2, what do you do? How we get the voltage? So we know Vx should be equal to, we have a 4 ohm resistance here. So 4 ohm into current, right? So 4 into minus 5 by 6. How I got minus 5 there? Think about it. Okay. Okay. And we know this center is 2 volt, and another YB will be equal to 2 into, because 2 ohm resonance there and 10 by 7 is the current. 2 into 10 by 7. Okay. So total will come what? So total VAB should be, you just put this VA and VX by and 2 volt into this equation and you will get the result. That's the idea. I think that's also clear. If you are not, you just think about it and try to watch this again. I mean, go back and see it again. And if you're confused, still confused, let me know in the comments. I will try to answer that. Okay. So we have solved two problems in K using KVL, and that should be good enough. Maybe we can try one more, but yeah, that's enough. I will suggest you to try more problems. You can just search Google KVL problems or something, and you'll get a good problem sheets. And you can do it, or you can just search in the images and you can see the problems as well as solutions in the Google. So you just watch that. It's not that hard. You can just do it. Okay. So that is it, and we have. So we have pretty covered KVL and KCL and its problems also. KCL also comes this way. We can use it in that same way. And another important thing is another. So we were talking about the tools in electronics, right? For any circuits, we have tools. We have a different kind of tools in electronics for analyzing electronic circuits. uh, I will just name a few, and let's can just search about it and see like what are the how we do use this and or. So I will just just right. We have tools in electronic circuit analysis. Tools for circuit analysis. First one is nodal analysis. Second one will be mesh analysis. Third is we call it as reuse methodology. Sorry, I should. Yeah, we call it as a reuse methodology. That's simply like whatever the results we got from the first and two, we will just remember that and use it in this method. So you can use it to simplify in circuits. Okay, and the fourth one is a superposition principle, and the fifth one will be as you already know, Thevenin and this Norton equivalent circuit. Thevenin and Norton equivalent circuits. So that is the tools basically using for electronics circuit analysis. But most of these tools we will use it for only for linear circuit elements. Linear in the sense, for example, if you are looking into the Thevenin. So Thevenin, you have a complex linear circuit. You have a lot of resistor, you have a lot of capacitor. I mean, everything is, and it is a complex circuit. So this linear circuit you have, and for example, you have another more circuit here. Any circuit. Okay, I'll just write any circuit. Okay. So the I'll just for okay any circuit. Okay. So the idea is this big complex circuit. I will just represent it as a voltage source and a voltage and resistance, which is resistance is R Thevenin and voltage is voltage Thevenin. So this will be I will just change it like I have voltage source and a resistance, and that this is the any circuit. So you will be simplify this big one into just a voltage and R Thevenin. This with a voltage and resistance, so with the voltage and resistance, and this is called as a Thevenin equivalent circuit. You have this, in the same way you have a Norton equivalent circuits, but there instead of the voltage source you will have a current source. For example, this like you have a current source and you have a we have a resistance. This is your any circuit, just any circuit, have another resistance. So with the current and resistance, we are represent the that big circuit, and here in the Thevenin, you'll have a voltage and resistance, so I represent the big circuit. So that's it. And but the thing is, like for all this, you need a for representing like this, you need a linear circuit, or the element should be linear in the sense like the voltage and current should follow a linear. For example, if your equation like we have voltage and current are related like V equal to Ki, then it is linear, then it is linear. If you have V equal like something like Ki square, then it is non-linear, right? Then it is non-linear. And in electronics also you may be here like active and passive elements. Active and passive elements. So what are they actually? So if an element, if a circuit element, for example resistor, anything, okay, if a circuit element has capability to enhance energy level of signal passing through it, then it is a signal passing through it. Sorry for my handwriting. Okay, signal passing through it, then we will call it as active element. For example, you have a semiconductor. If you have a semiconductor, then these are all active elements. Okay, because it will affect the energy level. For another example, if you have a resistance or capacitor or something, this will not enhance the signal energy level passing through it, right? So it is like these are called as passive elements. Passive elements. And for example, the resistor, inductor, or anything, inductor or capacitor or thermistor or anything which do not have any intrinsic the signal boosting capability, these are called as passive elements. And others like semiconductor or vacuum tubes or like other kind of elements are called as then active elements. Okay, and I think that is enough for this class. We have discussed an example of KVL, and we have started how this different tools for circuit analysis like Thevenin and the nodal analysis, mesh analysis. I will explain in detail. Maybe in this class I will talk about the capacitor and the importance of capacitor, and other after that, maybe after that and subsequent classes we will discuss each of this. For each class you'll nodal analysis we'll study the theory first, then do an example, then mesh analysis, then superposition, then like also example for Thevenin Norton we will do. Because if you see the past question paper like in JAM also or GATE or usually in the last long before they directly used to ask Thevenin Norton, and they'll just give a circuit and ask you to find Thevenin Norton and resistance and all. So since it is a simple one, like everyone will get the score and you should not miss it. Okay, so we will look into it each in detail. Maybe in coming, not in the coming class, maybe in the subsequent class. Okay, so next class we will talk about the capacitor and how the capacitor works and why we need a capacitor, that like that. So yeah, I think that's enough for today. We'll meet you in next class.